The vertex is always the opposite sign of the one inside the parentheses and then the one outside. So you can see it here. The coordinate of the vertex as -3, which is the opposite of the +3 here, and then the -4, which is repeated. Hi, my name is Mr. Joe. Welcome to my study room. If today is your first time, then I strongly encourage you to subscribe to this channel as we learn together. Today, we are studying about transformations on quadratic functions. This simply means what are the movements or the shifts of the parent quadratic functions. F of x equals x squared. In this study, I'm going to talk about the horizontal shift, the vertical shift, the vertical stretch, and then the reflection over the x-axis or the flip. Right, let's get deeper into the study now. For us to be able to tell the transformation on a quadratic function, it must be written in the vertex form if it is not graphed. And someone may ask, what is the vertex form of a quadratic function? The vertex form of a quadratic function is f of x equals a parenthesis x minus h all squared plus k, where hk are the coordinates of the vertex. That is, the vertex is h comma k. Alright, as I said earlier, this is the quadratic function written in the vertex form, and each part here, a, h, and then k, each of them have their own meaning, and I'm going to devote this time of the lesson to that. And I'll start with the h, which is the horizontal shift. Let me write that. Right, the horizontal shift tells whether the graph of this parent function here shifts either to the left or to the right, meaning if the general form of a quadratic function ax squared plus bx plus c is written in this form, then the value in place of h tells whether the graph is shifted to the left or to the right. And the graph shifts to the left when h is greater than 0 or positive. Let me just write that quickly. And to the right when h is less than 0 or negative. For example, when we have a function f of x equals x plus 4 all squared, because the h is positive, that means the graph has shifted to the left 4 units. And another example of, let's say, f of x equals x minus 2 all squared, meaning that the graph has shifted to the right 2 units or 2 units to the right. And I'm going to demonstrate that using a graph. And I'm going to use a graphing calculator called Desmos. So let's get onto the computer and check that out. We start by typing www.desmos.com. Then we select graphing calculator. Right, and it brings you to this interface. I'll first start by typing the parent function y equals x squared. Alright, so this is how the parent quadratic function looks like. It has a vertex with coordinates 0, 0, and the anchor points are 1 and 1, 2 and 4, 3 and 9, 4 and 16, 5 and 25, and so on, because for every value of x, the y will be x squared, right? So that is it. And the same thing happens to the left side, -1 and 1, -2 and 4, -3 and 9, and so on and so forth, because the graph is symmetrical. So whatever happened to the right hand side also happens at the left side. Today, I'm not talking about the features of the parent function, so let me go straight to the examples we have. So when we take our first example, which is y equals x plus 4 all squared, remember I use f of x is the same as y, so I can decide to use y or f of x. So y equals, remember to use the parentheses. If you are not using the keyboard, you can also use the digital keyboard here. So parentheses x plus 4 all squared. And we explained that the vertex of the graphs are shifted to the left 4 units. So you can see that this is the parent function, and this is how we know it has the red background. So the red one is the parent function, and the blue one is a new one that we've done. So a positive 4 here means that the graph has moved to the left 4 unit, and we can see that. So this is the vertex of our graph, and you can see that it has moved to the left 1, 2, 3, 4 unit. So that is that. Then we take the second example, which is x minus 2 all squared, and we explain that means the graph has moved to the right 2 units. And as you can see from here, this is the graph of the parent function, and when we check it, the vertex has moved 1, 2 unit to the right. So this is how we explain the horizontal shift. Any number in the parentheses tells the direction based on whether it is minus or plus. That tells us the direction and how many jumps it has moved. So all horizontal movements are in the parentheses. Let's now go check out the vertical shift. Alright, so with the function written in the vertex form, the k outside the parentheses tells us whether the graph of the parent function has shifted up, which is above the origin where the vertex of the parent function is, or down, which is below the origin, which is where the vertex of the graph of the parent function is. So let's see what that also means. A positive k tells us that the graph has shifted up, and a negative k tells us that the graph has shifted down. Let me write that quickly and then we take an example. Right, so I've just written everything I said. Shift up when k is greater than 0 or positive, and shift down when k is less than 0 or negative. And we take some examples. When we have y equals x squared plus 5, this means that because this is our k positive, it means that our parent function has shifted up 5 units. And another example will be y equals x squared minus 1. And because this is negative, it means the vertex of our parent function has shifted down or below the origin 1 unit. And we can just verify that quickly in Desmos. So I'll keep my parent function, which is the red one, and then I'll put in my second function. Alright, so like I explained, y equals x squared plus 5 is a shift 5 units up. So you can see the vertex of the parent function, which is red, and then the blue one has shifted 5 units up. 1, 2, 3, 4, 5. So that is 5 units up. And then let's check that of 1 unit down. Right, and we can see that too. The vertex has just shifted 1 unit below the parent function. So that is a vertical shift. Then now let's look at stretch. Taking our original function in the vertex form, we will say that the a here is called the vertical stretch. And what it does is that it tells us whether our new graph will be wider than the graph of the parent function, or it will be narrower than the parent function, depending on the value of a. And how do we know? Yes, we know the graph becomes narrower or slimmer or maybe stretched than the graph of the parent function when a is greater than 1, and then it becomes wider or flatter than the graph of the parent function when a is between 0 and 1. Let me write that quickly and we're going to show that on the graph. Right, so I've just written everything I've said so far, and then after that we go back to Desmos to demonstrate that using the graph. So I said that the graph will be narrower when a is greater than 1. For example, the graph of y equal to 2x squared will be narrower than that of y equals x squared, which is the graph of the parent function. And then that of y equals 5x squared is also narrower than that of y equals 3x squared, and I will show that on the graph for all of us to see. Then also the graph becomes wider than that of the parent function when a is between 0 and 1. For example, y equals 1/2 x squared, which is the same as 0.5 x squared, will be wider than that of y equals x squared, which is the graph of the parent function. And then the graph of y equals 1/5 x squared is much wider than both of them. So basically we can say that in the case of the stretch, which makes the graph narrower, the bigger the a, the narrower the graph. And then when it comes to the compression, which is the wider part, the bigger the denominator, or the smaller the a, the wider the graph. Then I ended with the third point, which I feel like is very important, and I will demonstrate that on the graph, that the graph reflects or flips over the x-axis when a is negative. And I have examples here. So for example, the graph of negative x squared, negative 5x squared, negative 2 parenthesis x minus 3 all squared will all face downwards, because all of this graph will reflect over the x-axis. That means each of these graphs would have been facing upwards, but because of the negative sign, each of them will be facing downwards. So let's get back into Desmos and let's show all of that starting from this side. So again, I will leave down the parent function, which is y equals x squared, and then I'll start working on the other ones so that we can compare both of them. So this is the parent function. Then when I have 2x squared, we say that will be narrower than the parent function, and as we can see from the graph, this is the parent function red, so we have it here, and you see that because of the 2, it's now narrower with the scale factor of 2. So this graph has stretched by the scale factor of 2. And then we take the next one, which is y equals 3x squared, and as we can see, this is green. Again, like I said, the bigger the a, the narrower the graph is, or the more the stretch. So this is stretched by a scale factor of 3, so it does become narrower than the first two, and that is the green one. Then let me take the last one, which is 5x squared. And then this looks like blue, so let me take out the blue, but we can see that that is the one further inside, so it looks much narrower than all of them. I can decide to bring the blue back, but the colors are different. Maybe let me say violet. So the violet one is the one with the 5, the a has 5, and it looks narrower. So the bigger the a, the narrower the graph. Then when we come to that of the compression, I'm just going to change each of them. So when we have this, the compression, we have our parent function again. And then we said that 1/2 x squared is wider than the parent function. So let's see 1/2 x squared. Y equals 1/2 x squared. Right, so 1/2 x squared is a black one. We can see that it is now wider by a scale factor of 0.5, which is 1/2. So it looks bigger than the parent function. And then we try 1/5. Y equals 1/5 x squared. They both look red. Let me see if I can change the color quickly. Right, so there we are, green. So the green one is the one with the 5 as a denominator, and it looks wider, or it looks more compressed than that. So that is how to tell. Then I spoke about the reflection over the x-axis, that the only difference that makes is that when the a is negative. So I'm just going to try with the first one, the black one. I just put a negative sign in front of it, and you can see that the graph has reflected over the x-axis. And then I can try this one too. So anytime there is negative in front of the a, the graph automatically switch or reflect over the x-axis, or flips over the x-axis. That is what happens if you put negative in front of the parent function. It flips it to be facing downwards. But then that is not all. We can have a combination of all of this. So let's see how that works. Let me have my parent function. Right, there you are. Then let's try something like y equals x plus 3 all squared minus 4. Let's see. Right, So by what we've learned so far, if you want to describe the transformation of this graph, can you pause the video and try that? Right, I'm sure you will tell me that this graph has shifted to the left 3 units because of the +3 here, and then down 4 units. Let's check that from the graph and see. So this combine both horizontal and vertical shift together. So let's see that from the graph. And there you are, we have a blue graph here. This is the vertex of the parent function. You see that it has shifted to the left 1, 2, 3, and then down 4 units 1, 2, 3, 4. So that is how you tell that this is the transformation of this graph. So it also means that if you are given this equation and you are to graph without using a table, you can just put the vertex, which is -3, -4. I will have a different lesson where I talk about the vertex of the graph, but then the vertex is always the opposite sign of the one inside the parentheses and then the one outside. So you can see it here. The coordinate of the vertex at -3, which is the opposite of the +3 here, and then the -4, which is repeated. But this is not all. We can still take more examples. Another example can be alright, so if I ask you to pause the video and try to describe the transformation on this graph, what are you going to say? Pause and try. Alright, I'm sure you are going to say that this is the parent function or the vertex of the parent function shifting 4 units to the right because we have -4 here, and then 1 unit up, and then that is not all. There is also a stretch here. So there's a stretch by a factor of 5. Let's see how the graph looks. So that means that this graph will look narrower than the parent function because of the stretch 5 here. Let's see. So there we have our graph, the green one, and this is the vertex. We talk about the horizontal shift first, 4 units to the right because of the negative. So we have 1, 2, 3, 4. Right, you can see that, and then 1 unit up because of the +1 outside. And then this graph has a vertical stretch of 5, so it looks narrower by the scale factor of 5. Then we try one more. Alright, again I would like you to pause the video and see if you can tell the transformation of this graph. And I'm sure you'll be able to tell that because of the plus here, it means that this graph has shifted to the left 3 units and then up 3 units, and then there is a vertical stretch of 2 and also a flip. So this graph will be facing downwards. If you'll be able to say that, then congratulations. Let's check that and see. So this is our graph. This is the vertex shifted to the left 3 units, 1, 2, 3. We have it here, and then up 3 units as well, 1, 2, 3, and then we have the vertex, and then the flip shows that this graph is facing downwards. All right, so there we have the transformation on the graph of a quadratic function when it is written in the vertex form. And I hope this lesson has been of help to you. In other subsequent lessons, I'll be teaching more things about the vertex form of a quadratic function and also other things about quadratic graph. So if this lesson has been of help to you, then kindly consider subscribing for more videos like this. Till we meet again in my study room, it's a bye. Thank you.